Today's class. Because I think my screen is visible, right? Okay, so last class I started with the random variables, and I explained like what are the different properties of random variable, and how what are actually the first of all random variable. It's actually a simple thing. It's a mapping from like there is some sample space, and it's a mapping from sample space to a real number. So like there is h if you're tossing two coin, there is can be h tail head or tail. So simply, this can be if you want to consider x as your random variable, and if x is the number of head, so obviously this will be counted as two. This will be one. This will be one, and this will be zero. So this is the basic of random variables. In the last lecture, I discussed in detail, and you actually can see the recording itself. Then we move with the discrete sample space and continuous sample space. Then discrete probability distribution I introduced key. It will be from the obviously the countable sample space, and the property is this simple that if f(x) should be greater than or equal to zero for all the point x, and if you add the value of x at all the present x, then it will be 1. And if you want to calculate the probability of any point x, then you simply put that value in the function and you get the probability. So this was the thing that we discussed, and we also discussed some examples, like let's say we are defining an event x to be the number of heads in we're tossing up two coins. Then we have like how we can define the probability density function. Obviously it's a probability mass function because pdf is for continuous distribution. And we saw how you can draw the graph. Then we saw the cumulative distribution function, their properties. And simply if you're given some of the probability distribution table, how you can actually find the k. And actually similar questions have been asked in the CMI paper also. And then how you can find the probability, these probabilities also. So this thing we actually discussed. And I also introduced key. If you want to find the mean of a random discrete random variable, then the formula is this particular thing, and it's simply sigma x into probability of x in x is equal to x. So in last lecture we saw everything in detail, like how you can use this formula to find the expectations, or which is also called the mean, and this to find the variance. And then we ended the lecture with the last example that I think you all can do the same thing, that you need to find the value of k. Just apply the formula sigma fx is equal to 1, and put all the x and fx, and then get the value of k. Then you can find the mean and variance in the similar with the formula that I told you, and you can similarly find the CTF and its graph. But now at this point, we are starting with the continuous random variable. So discrete random variable, the sample space actually we have is the discrete. It's a discrete, it can be countable, but it means in the real life it may happen that we are having a sample space which is actually continuous. It may be some interval, some closed interval, or something, some open interval also. So these type of things can be there, like in the mathematics itself we have something called continuous function. Then similar things are there in the this part also. So let's see how these things happen. So random variable is said to be continuous if it can take all possible value between certain limit. Limit means there will be certain interval. Okay, so let's say this is from 4 to 5, or let's say you have x greater than equal to 4, less than equal to 5. So this is a limit. Okay, so if there is certain thing, certain random variable which is defined on the basis of something like this, means it can take all possible values within certain limit. So means in generally you will see that in random variable x greater than equal to 0, means some function fx is defined for x greater than equal to 0. It means that it takes all the values between 0 to till infinity. So it can also take 0.1, 0.0001. So it is defined for all the values. But in the discrete case, what we have, we defined for the means specific value. So x is equal to 0, 1, 2, like that. So this way we define the discrete space, but in the continuous space, we can define it on the basis of the interval. So x greater than equal to 0 means in the number line, if it's the 0, it takes all the values after 0. Okay, so this is what continuous random variable means. Okay, now the thing is that the probability, the if you have a continuous random variable, there is some property associated with it. The first thing is that PDF is like in the continuous random variable we call this particularly fx as the PDF, And in the discrete random variable, we call it a PMA, probability mass function, probability density function. Okay, so fx, a random variable x has the following property. So let's say fx is the probability density function. It's a function, obviously it's a function. Probability density function of a random variable x, then it has the following property. So like in discrete case, we saw that fx is greater than equal to 0. Here also fx is greater than equal to 0 for all the x belong to minus infinity to infinity. So it means that whatever the interval on which your fx is defined, but if you take your fx in entire domain, so let's say minus infinity to infinity, if you see your fx, it will be at least 0 or it's greater than equal to 0. Second thing is that if we'll second thing we just saw there, that in the discrete case is sigma fx is equal to 1 for all x. Similarly, similar thing is that if you integrate fx on the interval of minus infinity to infinity, you will get the value of 1. So these two properties are similar to what we have in the case of discrete random variable. Similar thing, if we had fx greater than equal to 0 there, here also we have fx greater than equal to 0. And second thing is that fx, you will integrate in minus infinity to infinity range, you will get a value of 1. So we will see actually some examples of this type of function. So overall the main definition, main everything about the this continuous random variable is that, if first of all it's a function, it's defined on a continuous limit, and it can take any value within the continuous limit. Second thing is that if fx is a some function, this is associated with a random variable, then it has the following properties. The properties, one is that fx is greater than equal to 0 for all the limit that you have. And the second thing is that your fx, this integration, if you do it between minus infinity to plus infinity, you will get the value of 1. So just these two things will allow you to solve a lot of questions. So like exams, it may be given that something, some fx is given, but it may happens that particularly, like in the discrete case, we saw some k, particularly this k value is given, and you need to find the k. So to find the k, you did say here sigma fx is equal to 1, but here you have to do integration from minus infinity to infinity, fx dx is equal to 1. Okay, so these two properties will allow you to solve a lot of questions based on the probability density function. Okay, so before discussing this note, let me discuss you something important. So let's say in particularly case of random variable. So let's say you this fx is your continuous random variable. Okay, continuous random variable. It's defined between minus infinity to infinity. Okay, let's assume this particular thing. So let's say want to find what is the probability x is equal to greater than equal to a. Okay, so you need to find this thing. So like when you will plot your fx. So let's say this is your fx. Okay, this is your fx. This is defined between minus infinity to infinity. So the first important thing is that whatever the probability you are interested in, it is the area under curve. So let's say here is the point A. Okay, and you want to find what is the probability that your particular random variable x is greater than equal to a specific value A. So this particular thing means whatever the reason. So this is the fx, your curve fx. So whatever the reason is, whatever the area is between this below the curve from A to till infinity, this will be your required probability. So in that case, we know that means this particular thing is calculated by a till infinity fx dx. Okay. So I think you all are means familiar with the integration part, like how to do integration, basic integration, right? Uh, Guys, can you hear me? Okay. Okay, so the simple thing is that whenever you want to find the any probability, so let's say it's not about the x greater than, let's say you want to find probability that b greater than equal to x less than equal to a. So this particular probability for continuous case means you have this particularly a, somewhere you have some particular thing, let's say this thing is b. So you need to find this particular area. So obviously this thing is given by a to b fx dx. Okay, so this is how we will calculate the probability between given limit. But obviously x will be random. X is your continuous random variable, and a and b are your limit point. This integral part you can't apply in the case of discrete random variable. In that case, you have to use the summation part. But obviously, like how this integration comes, it will go basic to the integration. So obviously, means how the integral part has been come. So obviously, if you have a curve and you are trying to divide into very small part, very small part, very small part, and then you are trying to take this whole part together, then this is converted into the integration. So this is not the thing I want to discuss. The main thing is that if you want to calculate the probability, the simple thing is that just you have to do the integration, and here your integral skill will be coming into picture. Like nothing much probability is there in this part. Just remember this particular thing. If you want to calculate the probability, then you have to do this integration. So it may happen that somewhere you encounter some difficult integration, some different type of integration. So that particular thing depends upon your integration skill. But obviously, the probability is how this is how you calculate it. Okay, the next thing and next important thing is that if in case a discrete random variable, the probability at a point. So like in discrete random variable, if you have let's say this fx is your let's say just go above. So let's say this particular probability, this thing is there minus 2, 1, 0, 1, 2, 3. So let's say you want to find a probability at point 1. So what you will do, you will particularly put x is equal to 1, and you will see what this particularly thing is. So this is whatever your case, on the basis of that you find your probability. But in continuous case, if you want to find a probability on a single point, it is going to be 0. So like let's say this is your curve. So what is the area between a single point? It is negligible. It is infinitesimal. It's infinitely small. So it's taken as 0. So this means that if you want to find a probability at any given point, which is so this means the probability at a point x is equal to c is not 0 for some fixed c. This is the case of discrete random variable. But in continuous random variable, if you want to find some probability at some any fixed point, that particular probability is going to be 0, whether that point is in the range or not. So let's say your fx is defined for 3 to 5, okay, x 3 to 5, and you want to find probability at x is equal to 2. So that probability is going to be 0. You can find probability only between an interval. So let's say it's given at find a probability between what you can say x greater than equal to 2, or maybe x less than equal to greater than equal to 2 but less than equal to 2.5. So this type of probability you can find, but obviously you can't find probability at any point because that probability is going to be 0. We'll see with some examples like how to calculate these probabilities. So I think this thing that I've discussed till now is clear with you all. Just let me know if you have any question. Yeah, yeah, definitely. I will give the example. I'll just concept is clear. If Okay, so if you don't have any questions, then let's move to the next part. So before moving to the next part, just let's see one example. Okay, so the example is about the example is about the diameter of an electric cable, say X. So there is an electric cable. Okay, so this is let's suppose this is an electric cable. The diameter X is assumed to be a continuous random variable with PDF fx is equal to 6x 1. So this is a continuous random variable that this is given to you, and it is saying that the diameter of the electric cable X. So X is following a random X is a random variable which is following this continuous distribution. Okay, so this is a probability density function for fx. So fx is the probability density function of x, and like first of all, the question is check that above is a PDF. So I told you for any fx to be a PDF, the simple thing is that you have to find minus infinity to infinity fx dx, and if it is 1, if it is going to be 1, then you can say that your particular thing is the pdf. Okay, so let's do this calculation. Minus infinity to infinity 6x 1 minus x dx. Okay, the simple thing is that this particular pdf is defined between 0 and 1. Okay, so what about x less than 0, and what about x greater than equal to 1? So if any particular PDF is given in a particular range, it means that apart from this particular range, the PDF is 0. It is assumed to be 0. Okay, so this is by default, you know it. So like you can exclusively break this particular thing into three parts. Okay, the first part is minus infinity to what is the first range? Minus infinity to minus infinity to 0 fx dx. Okay, then plus 0 to 1 fx dx, and then 1 to infinity fx dx. But these things are going to be 0, so these things we are not considering it. So overall you are left with this particular thing. Okay, so obviously this you can't write this way, so just write either the fx, later we'll put the fx. Okay, so this particular thing reduced to this particular thing, 0 to 1, 0 to 1, 6x, what is it? 6x, 1 minus x. Okay, then you will do the integration. So I don't know how much I can do the integration. X minus x square dx, and then 6 into x square by 2 minus x cube by 3. Okay, this is 0 to 1. So when you will do this particular calculation, you will get the 6 into 1 by 2 minus 1 by 3. So this will be 6 into 1 by 6, which is 1. Okay, so this means that this particular thing is the PDF. So whenever you have some function given and you want to calculate if it's a PDF or not, simple thing, just calculate this integral part. If it's a 1, then you have a PDF. Okay, so you can see that I told you specifically to calculate it minus infinity to infinity, but here you know that this particular PDF is defined for 0 to 1. So obviously for minus infinity to 0, it's this particular thing is 0, and from 1 to infinity it's 0. Okay, so it's like, like let's say this particular thing is a number line, so this is 0 1. So there is this is some function between 0 and 1, otherwise it is 0, this way it's also 0. So this particularly range you have to take during the integration also. So I think this particularly this part actually itself is clear, like how to calculate the probability. Obviously, how to prove that fx is the PDF probability density function. Let's now just see some probability example. Okay, like how we can find actually some probability. So the second question is determine number A. Okay, so let's see this example. Determine a number B such that probability of x less than b is equal to probability of x greater than b. Okay, so this means that let's say this is the 0 and this is 1. Okay, this is 0 and this is 1. So this is 0 and this is 1, and this is number b. So number b should be such that if you want to find a probability of x less than b, okay, so this probability in this particular region and probability in this particular region, both the probabilities should be equal. Okay, so this is the concept that you need to follow. So I have explained the same thing very easily. So you need to find this thing such that means this particular probability are equal. So you need to find a b. Okay, now to find a b, the simple thing is that B will exclusively lie between 0 and 1. Obviously, the random variable is defined between 0 and 1. So 0x less than equal to 1. So if it cannot happen at B is outside below the 0, because in that case the probability will be 0. This probability, any probability will be 0. Or the probability that x is greater than B. So in that case also probability will be either 1. So this means that B should lie between 0 and 1. So let's say B lies somewhere between 0 and 1. It's not the middle point. Let's say it's lie between somewhere between 0 and 1. So in that case, we know that if we can find this probability of x less than b, what is it? You just take the smaller part, which is 0, and go till the point b. So this is b fx dx. Okay. And next probability is probability x greater than b. So x greater than b means from b to point 1. Okay, it should be from b to point infinity, but obviously infinity is not in the range, only 1 in the range. The higher point, the upper point is the 1. So in that case, it will be b to 1 fx dx. Okay. So similarly, this particular thing are there. Then you can just put the value of fx, which is 6 into x 1 minus x. Both ways 6 will be get cancelled, and this particular integration will be there, and which will be the part of your, like this particular integration. Then you can put the limit. You can put the limit in the both the side, and you can solve for b. You will get a cubic equation in the b. Okay. In that case, you can just break this part break this equation into two part. Here you get b is equal to 1 by 2, and here you also get some value of b. But the thing is that actually b is equal to 1 by 2 lie between 0 and 1. Okay, so 0 and 1, it's lie between 0 and 1. So it means that b is equal to 1 by 2 is our value of b, where this both probabilities are equal. Okay, when you solve this thing, you'll also get some point, but I think this point is going to be greater than 1 or maybe less than 0. So that's why we're not considering this equation, but we are just considering this 2b minus 1, because this point 1 by 2 is getting, it is actually between 0 and 1. Okay, so like there can be questions of this type. Let's say we are getting a three value of b, but we have to check only those. We have to take only those value of b which is actually lying in the range. So range means obviously if some b is 1.2, it can't be the big value of b, because our domain of interest is the zero between 0 and 1. So you have to take only those points. So this way you can obviously do some probability calculation and find this b. So is this thing clear with you all? Is there any questions or confusion? Um, Okay, so in means obviously I just skip some parts. So if you just understand how to like basically find probability density function, prove probability density function, and then some find basic probability, then in that case obviously like how what this particular thing means, what this particular thing means. Obviously it's talking about b to till your next upper limit. Okay, but obviously this function will be not given in this way. It can be like a lot of breaking the function, like it can be divided to four part of five. We'll see some example, but before that let's discuss about some important point. So one of the important result here is that, so this particular thing, like let's say x is a random variable and you want to find the probability of x less than alpha, or x means this particular probability that x lie between alpha and beta. Okay, or here just here, let's see this particularly equal to things. Okay, just here both are equal to sign. Here equality is not involved, and here the equality is not involved. Here there is no any equal to between alpha and beta. So these all probability are going to be same. Why? Because I told you ki in continuous random variable, finding probability at any specific point is zero. So if you are trying to find probability of x greater than equal to 6, or probability of x greater than 6, both the probability are equal, because probability of x equal to 6 is going to be zero in the case of continuous random variable. That's why this particular thing, both the all are going to be same in the case of continuous random variable. But if it would have been a discrete random variable, this means that you have to consider all values between alpha and beta, and you have to also consider alpha, and you have to also consider beta. This means that you have to consider all values between alpha and beta, but consider alpha but does not consider beta, because there is no equal to sign. So these things are there in the continuous random variable, that if you want to find any probabilities like this one, this way or this way, all the probabilities are going to be the same. So obviously, because at any point, if you want to find a probability, that is going to be zero, and this explains why this both the things are all the things are going to be the same. Okay. Next part that I want to discuss is the some measures of central tendency. Okay, so this is not very much important, but obviously you should know, because it may sometimes it may happen. Sometimes it may be asked for to you. Okay, so the first thing is that arithmetic mean. So like in a discrete random variable, the arithmetic mean was sigma x into fx dx. Okay, and we have to just do it for all the x that we have in the fx. But in the case of continuous random variable, obviously we are going to replace this sigma summation by the integral sign. So integral a to b fx into fx dx. Okay, so this is a sorry, this is not the dx. So this is the your this is your arithmetic mean. A, what is a and b? A and b is the range of your fx. So let's say your fx is defined between a and b. Okay, so in that case, your arithmetic mean is going to be integrating the whole range, then multiply x, same thing, and fx, and just do the integration. So this particular thing will allow you to get your arithmetic mean. Okay, harmonic mean similar way, just if not some equal. One by h is equal to one by x fx dx, and your geometric means can be calculated by using this formula log g is equal to log x fx dx. But these things are not so important. Only arithmetic mean that you should know, like how these things are calculated, and like geometric mean, harmonic mean is knowing, no one going to ask, especially in the paper of CMI. There is nothing going to be in the case of geometric mean, harmonic mean for continuous distribution. But you should know this thing. Okay, but just wanted to include these things. Okay, this rth mean means this is called what do you say, central mean about origin, something like that. It's rotated. So it means that expectation of xr, it means that this is something with expectation of x to the power r is equal to obviously a to the b x to the power r fx dx. Okay, so this is the simple rule that I have also told you in the discrete class also. Ki, just like let's say you want to find expectation of x, just do x fx. But if you want to find expectation of x square, then do sigma x square fx. And similarly, if you want to find expectation of x to the power r, x to the power r fx dx. Similarly, this is what this is representing. So you want to find expectation of x r in the this continuous case. Similarly, a to b x to the power r fx dx. Okay. So in this way, you can just integrate this part. This will be obviously a function. Fx is a function, and if you multiply by x to the power r, this is going to be a different function. And you want to you need to do this integral part to get the rth central rth mean about the origin. But obviously, you don't need require this formula. Mostly, you just want to find expectation mean or variance, and variance is equal to expectation of x square minus expectation of x the whole square. Okay, so this thing you will get from the mean, and this thing you can calculate from the uh, this thing you can calculate from this particularly r thing. So this thing means that sigma a to b x square fx dx. Okay, and we do this particularly minus thing, both the thing, and we'll get the variance of x. So this is a max you can need to calculate in case of CMAC paper. But obviously, when you will explore the books of probability, like Gupta Kapur book that I exclusively advising for this particular thing, they're having a lot of questions based on the mean, median, mode. Arithmetic mean, geometric mean. But if you are practicing from that book, just keep in mind that you don't keep practicing each and every question. Just obviously, if you see the paper of CMI, everything is not so difficult. Just you need to have the basic knowledge and basic practice, and you can solve the question. So we will move into the some questions of that type also. So this thing is about like some basic thing about central tendency. Obviously, median, if you want to calculate, so median is a point which divides entire distribution into two equal parts. So, let's say this particular thing is your distribution. So, if this particular thing is a median, it means that when you calculate this particular probability, and you calculate this particular probability, you will get the same thing. Okay, both are equal. So this means that m is the point where if you just from minus infinity to m you go, and from m to infinity you go, you get the same probability. So let's say x is defined between a and b. So a to m fx dx is equal to m to b fx dx. So this means this is a, this is your m, and this is b. So m is the median. So this probability a to m, this is going to be equal to m to b. This particular thing, this is 1/2. Okay, and that's how you actually solve here. Like if you find this both probability to be equal, you get the particular value of b. So here b comes to be 1/2. So this means that 1/2 is the median of this particular distribution. So obviously we'll see some more example, but first let me know if this thing is clear with you all. Guys, is this thing clear? Okay, now at this point, let's see some more examples. Like I told you, fx is not going to be a simple function. So let's say here fx is your defined between different range. Okay, so between 0 to 1, your fx is ax. Between 1 to 2, it's a. 2 to 3, it is a minus x plus 3a, and 0 elsewhere. Means less than 0 and greater than 3, it's a 0. Okay, so this particular distribution function is given to you, and it's a continuous distribution function given. So you need to find the do these two things. You need to find the value of a, and you need to find the value of x less than 5. So these particularly questions, I mean similar questions have been asked in the CMI paper also. So just let me show you the that particular questions. And actually, I also okay. So let me just show you that particular question. And okay, so I think I should have just found the question and kept it for you, but no problem. Okay, so see this question number 14 also. Okay, this question number 14. So it's saying that you have to y is a continuous random variable that takes value between 0 and 1. So obviously x, obviously the small y is greater than equal to 0, less than equal to 1. And you have some distribution function given. Okay, so gy is equal to cy square, and this particular thing is between 0 and 1. So you need to determine the c, and if you just determine the c, find a probability that y is greater than 0.8. Means probability that y is greater than 0.8. So like similar questions, so you can just practice these questions after the lecture. So the similar questions I have also. So fx is like it's some complicated things, some defined in some different part. You need to find the c, and then you need to find the you need to find this particular thing about value of a, and then you need to find the what is x less than equal to 1.5. So similar questions has been asked. So at this point of time, to find the a, simple formula that I told you, just obviously fx dx is equal to 1 in your whole interval. So minus infinity to infinity you can take, but you know that from minus infinity to till 0, this is going to be 0. That's why we have not included part when we started from 0 to 1. So how you are going to do? You are going to break this integration to different part, like the way you do integration for this piecewise function. So what you need to do, just from 0 to 1, it's a ax dx. From 1 to 2, it's a dx, because this is a definition of this. From 2 to 3, it's going to minus x plus 3a, and you have to integrate this whole function and then equal to 1. So like we do bunch of integration, if simple integration it is, you get a is equal to 1/2. So obviously you have, if fx is equal to some single function, some not a piecewise function, just or obviously you need to particularly calculate this thing integration. But if it's a divided into different parts, you have to do different integrals by breaking them into the part that you have. And just you all are mathematical students, so you know, like obviously this integration is just a simple integration, and you have to calculate the value of a to be 1 by 2. Now at this point you want to find what is productive x less than 1.5. So obviously productive x less than 1.5 means entire minus infinity to 1.5. Okay, but we know that this particular thing is going to define between 0 and 1, means from 0 to till 3. So this means that minus infinity to 1.5, but this thing is going to be 0 because obviously it's given that your integral, your integration, your function is 0 elsewhere apart from this range. And in that way you can see that okay, this particular thing is 0, so you have to just break into two parts from 0 to 1 and then 1 to 1.5. So you break 0 to 1, which is ax dx, and from 1 to 1.5, which is a dx. Means a, the particular function is a only. Okay, so this is the a that you can see here. Okay, so obviously you need to break your part because you know, like the definition of function is something different from 0 to 1, and it's going to be changed after the 1. That's why we are changing this part. And if you just calculate it, do the integral part, and then we will get some value in the terms of a. So a is the 1 by 2, so your probability that x less than 1.5 is the 1 by 2. Okay, so overall, this is the means a simple procedure that you use to calculate the probability in case of continuous random variable. So just two, three different things. This particular formula to find a and k that you will be missing from your distribution, and to find this type of probability, just you need to do the simple integration. Obviously, if it's a breaking into different part, just need to change the function at each interval. So you know, like we have different function for between 0 and 1, different function from between 1 and 2. So it's 1.5 from minus infinity to 1.5. It means that 0 to 1.5. It means that from 0 to 1, you will have some different function, 1 to 1.5, you will have some different function. And that's why we have break this part into this two way and just calculate a simple integral and get to the value. So, is there any problem with this particular questions or understanding how to find probability or integral, anything? Sum of probability means it's just a simple function, means there is no any piecewise function. Yeah, yeah. Yeah, definitely, definitely. So in this case also you can check if the sum is one or not. Obviously, this way we are doing this now. So this thing we are just finding the a on the basis of this particular concept only. So anywhere you get a fx, if you want to verify if it's a PDF or not, just integrate it with minus infinity to infinity dx, break it into particular range, and you'll get the one. It's a different thing. Okay, so there is a one another example, but this example have some problem. But means obviously I did not find this problem when I started to solve it. So just we'll skip it and we'll see it some other time. But let's at this point just see some other example. Okay, so this particular example is the mileage C in thousand of miles which car owners get within a certain kind of tire is a random variable. So there is tires of the car, and what the mileage means, what the duration of those cars, those tires are. Actually, it's follow the continuous random variable, and it has a PDF of 1 by 20 e to the power minus x upon 20, x greater than equal to 0, and apart from that, it's a less than equal to 0. So obviously, obviously, don't, this is a exponential distribution. So obviously, I will just teach you the exponential distribution. Its form is simply, 1 by a e to the power minus x by a, or it can be a e to the power minus ax. So it has two form, but obviously I will teach you first thing, but the things that I included this example to get you a overview of how exponential distribution work. So the simple thing is that means the life of the tire actually depends on this distribution, and it is defined for x greater than equal to x greater than 0, and apart from x means x less than equal to 0 or some other thing, it's a 0 function. Okay, now at this point of time you have to calculate some probabilities, like this type of questions has been asked in the CMI, but for the normal distribution. So I may show you the questions also, but this questions has been there, so that's why I'm just including those type of important questions which has been included in the paper also. So obviously I need to find it, but obviously it will be the 2019 paper, the year in which I appeared. So okay, so if you just talk about the other thing, so like this particular thing, changing binomial into positive, actually these things I will teach you. So that's not any other thing. Okay, so here you can also see some simple questions of probability. Like this is a probability distribution given. You need to find the k. Okay, and expected value of the distribution. Expected value means I obviously told you that expected value means the expectation of x, which is uh, x f x dx. Okay, so obviously there is no such difficult questions of probability distribution. When cover, we will be able to solve a lot more questions. But I think that particularly. Okay, so there is a question of some random variable, but obviously we will see that question. But obviously, yes, means I've just included these questions for the explanation. Okay, to find a probability that the one of these tires will last, means let's say you choose one tire, and what is the probability that it will last at most 10,000 miles. So like this probability has been included in the terms of thousand of miles. So this means that 10,000 miles means, let's say x is the duration of your tire. So in this case, okay, so it's the network problem. So maybe we just wait for 1 minute. Is this thing? Is my voice clear now? Okay, so it's a network glitch. Don't worry about it. Okay, and so the question is that you have this particularly a PDF given, and you need to find the this required probability. Simple thing is that no need to worry. The simple thing will just do it in one way. So it thinks that if you have been given a particularly tire, then what is the probability that it will last at most 10,000 miles? So it means that if you have just a tire, what will be? It will be just less than equal to 10,000 miles. Okay. So since we are modeling this probability in the terms of thousand of miles, so we will be taking only 10 here because 10 means 10,000 miles. Obviously, this thing has been modeled in the terms of thousand of miles. So this thing is written in the prior. You know, it's prior to the question. Okay. So this means that if x is the life of tire, then what is the probability that x is less than equal to 10? At most means अधिक से अधिक 10 जा सकता है 10. So x less than equal to 10. So you need to find this particular probability with this distribution. So this particular probability will change to obviously from 0 to 10, this particular distribution, and it will do the simple integration, and we'll get the particular this particular thing. Obviously, like you can say that in the exam where we are getting e to the power minus 1 by 2. So that particular thing will be given in the question itself. So like this particular questions, you can see that a lot of different values of this distribution is given. So that's how if it's required in the questions, you will get those values in the question itself. So, but the thing is that you should know how to solve the question. That's the more important thing. So here, this particular thing at most 10,000 miles will be calculated into this way. Next thing is if you just choose a tire randomly, then what is the probability that it will last? The tire will last anywhere between 16,000 to 24,000. So obviously it means that the probability of that x is the tire of life. The x lies between x is greater than equal to 16 and less than equal to 24. Because if it is 16 means 16,000 obviously, and 24 means 24,000, and if x lies between all these things, we need to find its probability. So simple thing, just you need to do the same integration in the range between 16 to 24. And the last question is what is the probability to last at least 30,000 miles? At least means it will be greater than equal to 30. Okay, so you have to find this probability. So you can find this probability similarly by putting the things and doing the integral. So similar questions can be there in the paper and has been there in the paper. So definitely you can solve these questions to uh, practice. So is there any problem understanding like how to solve this question or how to solve any questions like this? Like a it's not like someone is going to give you the priority. Let's say they're saying, okay, find x less than equal to 2 and get an equal to 2 and less than equal to 6. It can be modeled in a word problem also like this way. And you to understand like how to convert this thousand into numbers because this thing has already been modeled in the number in the terms of thousand. So obviously these things will be there. Simple thing, just not there's no need to worry, just use the same formula, same concept, and we'll solve the question. So is there any confusion or questions regarding this particular problem? Yeah, yeah, definitely. We'll apply it by thousand, but obviously, that will be the no. Means if you're finding the probability, then how why we are going to find the probability? This particular thing has been given mileage seen the thousand of miles. So this particular probability is obviously this distribution is given for 1,000 miles. So it may be written that the mileage of a car tire is given in this way. So in that case, just take the 16,000 integral between 16,000 and 24,000. No need to worry. But it's specifically given that this particular probability is modeled in the terms of thousand of miles. So whatever the mileage will get. So let's say A will be put x is equal to uh, uh, x is equal to 2. Okay, so this particularly you found probability 0.399. So it means that this thing is for the 10,000 mile. Means I don't know why what is the confusion there. Means obviously it's given like it's modeled in terms of thousand of miles. Yeah. So means somewhere it may give indirectly that this particularly thing has been means like this is how they want to confuse the student. Okay, they are taking the 10 or 10,000. So they will not give this particular thing. They will just give it the mileage C in which a car owners get with a certain kind of tire. It's a random variable with PDF. This that. So in that case, you need to obviously apply this particular thing. Uh, that's how like you get to the probability. Okay, some more questions we have. So just if you don't have any problem understanding this question, so let's move to the some different type of question. So the question here is about solving. So there is a random variable x, okay, and it has PDF. Obviously, it's a continuous random variable. It is a PDF 2x between 0 and 1. So it's a 2x between 0 and 1. Otherwise 0. So you need to find a probability that x is less than 1/2. So this thing you can simply do, just integrate the thing between 0 and 1/2 and just 2x dx. Okay, but this is not why I included the question. The next thing is between the next part. Let's now focus to the three. Second part you can similarly solve it. Third part is what is the probability? It's a conditional probability. The probability that x is greater than 3/4 given that x is greater than 2, greater than 1/2. So this is your number line. This is your 0. This is your 1. So it is saying that x is, so let's say this is 1/2 and this is 3/4. Okay. So it's saying that what is the probability that x is going to be 3/4 if x is greater than 1/2. Okay, x is greater than 1/2 means from 1/2 to 1. So this probability we are asking. So we know that to calculate this probability, we need to take the means if there are two events A and B. If A given B probability we need to find, we just find it by probability of A intersection B divided by probability of B. Okay, so here you need to find probability that x is greater than 3/4 intersection x is greater than 1/2 divided by probability that x is greater than 1/2. Okay, so is this thing means this thing is translated into this way. So is there any confusion like how why we are doing this way? Anyone? And then we'll see like how we'll solve the probability. So means this thing can be written this way. The simple thing A intersection B means this particular event is A, this particular thing is B, and A given B means A intersection B by probability of B. So this thing is coming to the below. Okay. Now at this point of time, x greater than 3/4 and x greater than 1/2. What is the intersection? So x greater than 3/4 means this particular line. Okay, and x greater than 1/2 means, sorry, x greater than 1/2 means this particular line, x greater than 3/4 means this particular line. So this particular region is the common region. Okay, this particular region is the common in the both the line. Okay, so this probability will be get reduced to probability that probability that uh, let me just erase something. Okay, this thing will be get reduced to probability that x is uh, so this thing will lie between 3/4 and 1. Okay. So similar thing because this thing is common. So x probability x greater than equal to 3/4 and less than equal to 1 divided by probability of x greater than 1/2. Okay. So this thing you can calculate easily by doing the integral separately, and this thing you can calculate easily by doing the integral separately, and divide these two numbers to get this required probability. So simple thing, if you just consider encounter some probability of this conditional type of thing, simple thing, just take the integral part and this intersection part. And intersection means the common reason that you need to do. Okay. So is there any confusion understanding why you're doing this, and from this why you're doing this? Is there any confusion? Anyone? Okay. So I think someone is putting some message in chat. Okay, so if there is no any problem, then we just move to the next part, which is part number four, and we get more clarified. Okay, so in part number four, you can see that the thing is just asking the same way, but it's the probability has been reversed. Okay, So in that case, it is asking about probability x is less than 3 by 4. So if you just see the same number line you can see. Okay, so this is 0, this is 1, this is 1 by 2, and this is 3 by 4. So this is asking about what is the probability x is less than 3 by 4. So x is less than 3 by 4 means obviously from 0 to till 3 by 4. Okay, and x is greater than 1 by 2 means 1 by 2 to 1. So in this way you can see that the common part is this way, from 1 by 2 to 3 by 4. This part is the common between both the distribution. So this intersection that will do, it will translate into integration, that probability of x less than 3 by 4 integration, sorry, intersection x greater than 1 by 2 divided by probability of x greater than 1 by 2, and this particular thing will be translated into probability that x is between 1 by 2 to 3 by 4. Okay, 3 by 4, and this thing you can calculate by doing the simple integration between the interval 1 by 2 and 3 by 4, and then you need to divide it by probability that x is greater than 1 by 2, and just simple integration of 2x, there is no much complication there. So like this particular thing is simply 2x between 1 by 2 to 3 by 4 dx, and we'll get some number. Obviously when you will do this thing, you will also get some number, divide this two number to get the probability. So this is how you check, do conditional probability in case of continuous distribution. So guys, any problem like understanding anything regarding conditional probability or how to do this thing? If it's clear, then we'll move ahead. If you have any questions, just let me know. Okay, so at this point of time, we have discussed a lot of things related to discrete and continuous distribution. Obviously, there are different lot of things also. So these things are obviously for x only. So these things are called one-dimensional random variable, 1D random variable. There can be two-dimensional random variable also, but these things are not in our syllabus. These things are not for our interest. Obviously, preparing for IIT exam, then IIT exam mathematical statistics, then it would have been a lot of wide topics. But for now, the simple understanding of discrete, continuous, and standard distribution will allow you to solve the questions from CMI paper. So till now, we have discussed discrete distribution, and we have discussed a lot of examples of discrete distribution. Obviously, we have discussed a lot of things related to continuous distribution, a lot of examples like finding mean, variance, expectation. So expectation is same as the mean, and then find the conditional probability here, and obviously everything about integration, the simple formula, just this minus infinity to infinity fx dx, and this you will used to find k and a, whatever the missing value is. And you can see that there are a lot of questions regarding this in the your CMI paper. And obviously there's a lot of questions regarding this word problem. There are a lot of questions regarding the find these type of probabilities. So more than that, means these things will be there in the paper. It's continuously being asked these type of questions. So I think this will allow you to solve a lot of questions now from the probability section. So means your task is to just go and just easy questions are just the same similar questions changing the value, you will solve get and solve it. But obviously we'll start discussing standard distribution, and from the next class, and we'll cover some more distribution like binomial, then we have Poisson, then geometric, then exponential, negative binomial, then we'll also discuss normal distribution, beta distribution, gamma distribution. So just a simple introduction of each distribution so that you can solve each and every question, simple questions from this type of distribution. No depth knowledge of this distributions are required, because no nothing is actually asked, and why there is need to waste your effort, energy, and time. So these things will start from next class. But let's now just focus on some more thing related to distribution. So in the discrete case, we had some distribution function. Okay, distribution function. Okay, so in this case also we have some continuous distribution function, which is called CDF. Okay. Uh, Okay, so this is called cumulative. Sorry, cumulative distribution function. Okay, cumulative distribution function. So for continuous random variable, the cumulative distribution function is defined as the same way. So in that case, in the discrete case, we had minus infinity to sorry, this thing was the means add this all the thing over till the point x. This thing was ft. So this thing can be regarded as x. Okay, t less than equal to x. Okay, so this thing was there in the case of discrete distribution. So let me just show you the case of this distribution. So there we had this particular thing as the cumulative distribution function. But in the same continuous random variable, this thing is regarded as minus infinity to x ft dt. Okay, so this thing is called cumulative distribution function for the continuous random variable. Continuous random variable. So obviously, like if you just understand simple thing, in the discrete case, use the summation sign. In the continuous case, use the integral sign. Same formula will be used. Same type of intuition will be used. So that's why this particular thing is there, and this thing is there written in this form. Okay, so this is called cumulative distribution function. So this cumulative distribution function has some properties, like the PDF has some properties, PMF has some properties, so CDF has also some properties. So cumulative distribution function means if fx should be means the value of fx should be 0 and 1. So whatever the value of x you put, it should be between 0 and 1. Okay. The next thing is that if you differentiate your fx, so if you differentiate your cumulative distribution function, you will get your PDF. Okay, so obviously this thing you have to keep in mind, because somewhere your cumulative distribution function will be given and not the PDF will be given. So PDF will not be given, you will get only cumulative distribution function. So in that case, you need to integrate this part, sorry, differentiate this part to get the PDF. Obviously, like we know that PDF is always greater than equal to 0. So this is one of the basic properties of the PDF. So in that case, like from the calculus, we know that if some function, if you differentiate and the result you get is greater than equal to 0, so it means that that particular original function is non-increasing function. So obviously, CDF, cumulative distribution function, is a non-increasing function in X. Okay, so this thing we result we get from this point. Next property is minus. If you just calculate f minus infinity, which is obviously calculating the limit of x tend to minus infinity fx, it is going to be 0. And if you calculate f plus infinity, means obviously this particular thing, it's going to be 1. And the fourth property is fx is a continuous function of x on right, so it is a right continuity. Here you will get right continuity. Okay, so these four properties are the most important property for CDF. So I did not find any questions from the CDF in the semi paper, but I just wanted to know. It may happen that they include questions of this type in the next part, next exam. So CDF simply means that it's a function. It's a cumulative distribution function, just like the PDF in the discrete case we have. Just you need to follow these properties. Simple thing is that if you just integrate, differentiate your cumulative distribution function, you will get your probability density function, and when you will integrate this part, you will get back to the distribution function. Okay, so both is the vice versa. So somewhere you will get the fx, some will get the capital fx. The capital fx means you need to differentiate it to get to your small fx. Okay, and so let's say some example also. So let's say this particular thing is your capital fx, cumulative distribution function, and you need to check if this particular thing is what you can say, is it a distribution function or not. So first property is you need to check if fx is between 0 and 1. So obviously to check, just check at any point, like just put here minus a, you will get here 0, and if you just put here x is equal to a by 2, just you will get some value between uh, 0 and 1. Okay, so this thing is satisfied. The first condition is that, second condition is that if you differentiate it, you will get a PDF. Okay, so just we'll put this thing on hold for now. The next thing is that f minus infinity 0, f plus infinity 1. So f minus infinity, if you want to calculate, so f minus infinity means that limit x tend to minus infinity fx, capital Fx, and it is 0, because like for all the values between less than minus a, from minus infinity to minus a, it is 0. So that's why this particular limit is going to be 0, and this particular limit is going to be 1, because it's for all the value between a to infinity, it's 1. So these things are like understood for you. If you just practice some questions, you will understand how to calculate this limit. So fourth is the right continuity. So like till it's, for now, I can say this is right continuity. I will just include a definition of right continuity when I start the limited continuity for the math part. Okay, and if you want to verify this PDF part, just take the differentiation. You will get this thing. So this should be the PDF, and for this should be the PDF, you need to integrate it between minus infinity to infinity, and this translates into minus into a, and you will get the 1. So since this differentiation part is a PDF, and since all the conditions are satisfied, we have this particular part. This fx is the CDF of cumulative distribution function of any particular PDF. Simple thing, like just check all the condition, and obviously integrate the differentiate this particular part to get the PDF, and just need to check if this is the PDF or not. So to check this is the PDF, just integrate between minus infinity to infinity, and you will get the value of 1. So this is the PDF, and rest of the conditions are also satisfied. So this would be the CDF. Okay. So questions can be like this, like more or less questions can be like this: key prove that this particular thing is the CDF or not. So this is the way you need to proceed. Any confusion regarding understanding the PDF or CDF? Guys, if you have any questions, just let me know. Or if it's clear, just let me know also. I will just move ahead. Anyone just give some response at least. Guys, please give some response. Okay, so this okay, so this particular question is below that petrol means it's also word problem. So a petrol pump is supplied with petrol once a day, and its daily volume X of sales in thousand of liters. So has been given thousand of liters. Okay, so this type of things you have to do it. Okay, its distribution, obviously it's a consumer distribution. What must be the capacity of its tank in order that the probability that its supply will be exhausted in a given day shall be 0.01. Okay, so this means that let's say your capacity of tank is A. Okay, so it is asking that what will be the capacity of tank. So let's the capacity of tank is A, so that supply will be exhausted in a given day. So like let's say your X is the total sales of in thousand of liter. So supply end means your X is greater than equal to A. So if any customers, let's say, is equal to 100, and any customers comes and let's say they are asking for 110 liters, so it means that your supply will be ended. Means let's say your 100 liter has been already sold and someone comes from one more liter, it means that your supply is ended. This means that total sales will increase by means it should be greater than equal to A. So this probability will translate it into this way, like to find A such that probability of X greater than equal to A is equal to 0.01. So it means that the probability that this particular supply will end, it is 0.01. But how to find this A? Okay, so just first of all, just understand how this problem is coming into this probability. So it is given that the capacity of its tank in order that the probability that its supply will be exhausted. So let's say we are talking about this supply to be A, and it is exhausted means ended. So it will be ended only when the supply will be greater than or equal to A. So it obviously can take greater than A, it's not a problem. So this will be termed as they are saying that this particular probability will be 0.01. This is given here. Okay, so this thing is translated into this way. Obviously, at this point of time, you can find this particular probability by doing the integration between a to 1. Okay, a to 1. Why a to 1? Because this particular thing has been between 0 and 1. Okay, probability, and x must be between some point between here, something between here. Okay, a. So a to 1 fx dx, which means that a to 1 of 5 into 1 minus x to the power 4 dx, if this probability is equal to 0.01. Okay, so this integral will come in terms of a, and when you will do the calculation, you will get some a value, something in terms of a. But whatever the value you get, you have to multiply it by thousand of liters. Okay, so you have to multiply it by thousand to get the actual volume of actual capacity of the tank. Simple thing, just translate this way, just calculate this probability. Obviously, this is the probability question. A to 1, you have to do it. It will come in terms of A, and solving this equation, you will get some value of A, something value of it, let's say 0.4. And when you multiply this thing by the thousand, you will get the actual capacity of the tank. So this is how like this thousand of liters come into picture. There also it's saw that we need to do it for the probability, but here you are finding the capacity. So A will be something like, let's say, 10, but we know that it is in a thousand of liters, so we need to multiply it with thousand to get the actual volume of the petrol pump. So I think this clear questions clarify everything regarding PDA, PMF, or some word problem. Any questions, if you have, just let me know. Guys, any question you have? Okay, so from next part we will touch some topic of mathematical expectation, and then we will start the standard distribution. Okay, standard distribution will touch it. So this thing, mathematical expectation means expectation of x or variance of x. These type of things we will see. Covariance, correlation, some simple definition we will see, and from the next, then we will start the standard distribution. And I think the standard distribution will take 2 to 3 classes, because we'll just discuss some standard distribution with the PDA, PMF, and how to do some word problem from using the standard distribution. Because if you just see the question paper, you will also always find a lot of problems related to the, like here you can see Gaussian distribution is there. Some other distribution also has been asked, like Poisson binomial. So we'll touch those topics, and then our part of probability will be over. So obviously, we will once we calculate the probability, we had to enter into this discrete math part, because it's also containing a lot of things like set relation, combination permutation, elementary counting techniques, and then we may touch some school level mathematics. So like a school level mathematics is not so hard, because APGP, arithmetic progression, geometric progression, polynomial matrices. These are, like, if you just remember all the properties of matrices, you will be able to solve a lot of questions. Similarly for determinant solving questions. But like obviously you'll have problem in the function and some integral part, because like function, there are a lot of different types of questions can be there, which can be mixed with some different parts, like finding the roots and all those things. So obviously overall every questions you can solve by your own, like this particular thing is actually dependent on your properties of matrices. So obviously if you understand this particular thing, just do some counter example, you will be able to solve this particular questions. So then we will move to the, obviously move to the discrete maths, and then maybe we'll touch some topics from the school level, especially like differentiation, maximum minimum. Maximum minimum questions will be there. uh, and GCD LCM, I don't know from where I should teach you, because these things I read from a general aptitude book. So obviously you can see those questions, or you can solve it by your basic intuition also. So nothing like more any formula or something like that is given. So for divisibility, I'll suggest you to read some specific type problem. Like there's had some specific type problems in the reasoning. So let's say 2 to the power 50 is getting divided by 3. Then what will be the remainder? Okay. So these type of questions are there in the divisibility problem. So you can see those type of problems. Obviously, we'll start discrete maths after the probability theory, and we will do something. So guys, now you can start solving questions from your own also. So you can solve also a lot of questions, and so that was this from my side from this for this lecture. And obviously you can just watch the recording, and we'll have some other session also, like taste and the thing in the website also in the coming time. Okay guys, thanks for joining. Have a nice day. Bye.